DTO and the token request into their own files. And then let's take the token request and the access tokens DTO and move them into the off folder inside of DTOs. I will also adjust the respective namespaces, and I can close this down. Next, we need to register this with dependency injection. So inside of the dependency injection class, I will look for add application services, and let's add our token provider as a transient service. So let me specify token provider here, and now I can use it inside of my controller. So I will go to the authentication controller, the auth controller, and here we will inject our new dependency, which is the token provider. Let's specify the token provider, and finally we can use it inside of the register method to complete the implementation where we are returning the access tokens. So let's get the access tokens into a variable. I will call token provider, and we have to call the create method, which expects a new token request. The next thing we have to think through is which value should we include when we want to pass in the identity of the user. Because we're using ASP.NET Core Identity to manage authentication for our users, I will use the identity user object to pass in the user ID. We can use the same object to also pass in the email value. We can move this into its own variable. This will make it slightly simpler for debugging, and in the end I want to return the access tokens as a result of this endpoint. Finally, we can create our next endpoint, which is going to implement the login functionality, and let me create this method. It's going to be public async task. I'll pass in action result as the value that we will be returning, and we're going to return an access tokens DTO. I can also adjust the register endpoint to return this type, and this will improve our OpenAPI descriptions for these endpoints. So let's go to our login endpoint. Here we need a request object to represent our request body. So inside of the DTOs folder, or in the auth folder to be more specific, I will create a new class that I will call the login user DTO. Let's make it a record, and I only need two properties here, both of which will be required. The first one will be an email, and the second one will be the password that I want to use to authenticate with my system. Let's close this down, and then I can use the login user DTO in my login endpoint, and the framework can figure out to bind this from the request body. So what can we do next? Well, I can use the user manager to try to find a user based on their email. We have the email in the login request, and we get back an identity user. Now, this user might be null, which means that they don't exist, but I also want to check if the user's password is correct. I can do this by saying user manager check password async, which accepts an identity user and the password of this user that we want to validate. If this evaluates to false, then I'm going to return 401 unauthorized as the response of this method. After that, I want to initialize my token request. I'm confident that the email will not be null, so I will use a null forgiving operator. And then I can say access tokens and get this value using the token provider, which gives me back my access tokens DTO that I can finally return from this endpoint. This is going to encapsulate both my access token as a JSON Web Token and my refresh token, which is currently just an empty string. And here you can already see how ASP.NET Core Identity is doing the heavy lifting, and we can implement the login functionality in a couple of lines of code. Identity takes care of checking if the identity user exists in the database based on their email, and it's also going to perform the password hashing and confirm that it matches the password hash in the database so that we don't have to implement this functionality. Our only responsibility is generating a valid access token. So finally, let's start the application and test this out. If I send a post request to the login endpoint and use the credentials from our previous lesson where we registered our first user, I should get back an access token and the refresh token pair. And you can see that this is indeed what we get back in the response. Let's take the access token and head over to jwt.io. I can paste in the access token here, and we can observe the components of the JSON Web Token. So in the header, you can see the algorithm that was used for the signature. The token type is a JSON Web Token. our audience, issuer, subject, and email claims are all correctly set, and this subject here is from the ASP.NET Core users table. It also matches the identity ID of our user. And the third component is our signature here, where we can paste in the key that we used to sign this, and if this matches the value that was used to sign this token, we will see that the signature is verified. Finally, all that remains is to use this access token and see if authentication is working inside of our API. I will go into the user's controller, and I want to decorate this controller with the authorize attribute. This is enough to require authentication for all of the endpoints in this controller. Let's do the same in the habits controller, the habit tags controller, and the tags controller, which we already implemented in our previous lessons. And now let me start the application again. And let's say I send a request to get a habit by the ID. I should expect to get back a 401 unauthorized response, but for some reason I'm getting 404 not found. If we take a quick look at our structured logs, we may get an idea of what is happening. You can see that authentication is kicking in, and the default authorization requirement, which requires an authenticated user, is failing, but this is causing us to run into a challenge. And by default, with ASP.NET Core Identity, this will try to redirect us to a login screen, where we will have to provide the proper credentials before we can access our controller. You can also confirm this if you take a look at the distributed traces, and right here, after the request to fetch the habits, there is another trace, and if I open it, you can see that this is a GET request to the account login path. Now this is because of the way we initially configured our authentication services. Just setting the authentication scheme isn't enough, but you can update this to explicitly set the default authentication scheme and the default challenge scheme to use the bearer scheme, and then our authentication will work as you might expect from an API. So let's restart the application again. And now if I send a request to get back a habit, I will get back a 401 unauthorized response. This is what we would expect. Now let's go ahead and send a login request again. We get back a new access token, and I'm going to set it at the dev habit collection level. I will say that the authentication type is bearer token, and I will paste in the token value. And now if I send a request to get the ID, with the access token present, we get back a 200 OK response, which means our authentication is working as expected. You can also test this out in the other controllers that we have. For example, if I request the tags, I will get back the collection response that also contains the hypermedia links because I used our custom media type that contains HateOS plus JSON. And I think we can slowly wrap up our implementation of token-based authentication using JSON Web Tokens. In our next lesson, we're going to extend this to also support refresh tokens, which are long-lived compared to access tokens, and allow us to implement a better user experience for our clients.